So just some things that we're going to cover in order. We're going to go over all of that vocabulary that's parts of the parabola. We're going to do some graphing and identifying attributes. You are going to have an exit ticket, and your homework is going to be 7.1 day 1 homework in your packet. So let's just talk about what a parabola is. This is just a graphic that shows all of the shapes out of a double cone. It's 2 cones inverted. So if you notice, when we flatten this back out, you can have a straight line from a conic section. There's your circle. Notice it's parallel. When we slant a plane, it's an ellipse. When we have a parabola, it's just through one cone. When the parabola is tilted and the plane is tilted, it makes a hyperbola, which we'll talk about later on in this unit. Whoops, so sorry. Okay, so let's just go ahead and jump in, guys. So part 1 of your notes, we're going to talk about parabolas. And let's go over some definitions here. So just kind of remember that the set of all points in a plane is equidistant from the focus and the directrix. It creates this curve called a parabola. And the big thing there is everything is going to be equidistant from the focus and the directrix. So the vertex is a point that is on the parabola, and it's located between the focus and the directrix. Now, the focus is a point that is inside. That's pretty important. Inside the interior of the parabola. And the directrix is like a line. It's not like a line. It is a line that is located on the outside of the parabola. So let's go ahead and talk about P, because P is so important. All right, so we cannot do anything unless we have this P value, guys. It is the distance from the focus to the vertex, and it's also the same exact distance from the vertex to the directrix. So there is an official width of a parabola. It's called the latus rectum, and you can tell how wide the graph will be at the focus. And another word for this that I use a lot is called the focal width. And we're going to talk more about the focal width, but the focal width also has to do with P, and it is just 4 times the P value. So again, it's very, very important that we know this. And also remember that focal width is going to be the reciprocal of A. All right, so what we got going on now is we have 2 ways that we can make a parabola. We can make a vertical parabola, which you guys have seen before, very similar to like Algebra 1. And then we're going to have a sideways parabola. It's called a horizontal parabola. Here's just a little sketch. Here's your vertical. And go up or down. This is when the A value is positive. If it's negative, it opens down. So let's go ahead and just continue to fill out what we know here. So look at your vertex form, very similar to what you are accustomed to over the past couple of years. Your A value is a vertical stretch or a shrink. There's your horizontal movement, it's opposite in parentheses, and your vertical movement, of course, is K. Remember, guys, if the A value is positive, it opens up. If your A value is negative, it opens down. The vertex, of course, is always HK. And then, guys, your focus is going to be right in line with your vertex, but it might have movement. So the way that this is going to happen is the H value, it's going to share the same as the H value, but again, it's going to be sliding up or sliding down, and that's why P is so important. So let's talk about the directrix. The directrix always starts with the same letter the equation does. If it starts with a Y, then the directrix starts with a Y. Now, the directrix is just going to be, again, above or below. So this is going to be K plus or minus P, and we're going to talk about that. Just remember for right now, the directrix starts with whatever the equation starts with in vertex form. The axis of symmetry starts with the other letter on the coordinate grid. If that's a Y, the other letter on the coordinate grid is X. And it is going to equal what the vertex is for the X coordinate. So X equals H. All right, so also remember, guys, your vertical parabolas, these are functions. Because you don't have any X values that are going to repeat and give you different Y values. That is not the case for horizontal. A horizontal parabola, we can't call it a function. It's just a relation because it has more than one value for each input. So this is a horizontal parabola. Remember, it's not a function. We can call it a relation. Notice it starts with the letter X. And guys, if A is positive, it opens towards the right. And if it's negative, it's going to open towards the left. The vertex is still HK. But look, H is on the outside and K is actually going to be opposite for sideways parabolas. Now, remember, your focus is going to be right in line with your parabola. However, it's going to be moving to the left or the right by a value of P, which we're going to talk about. But it is going to be straight in line with your vertex. Same with your directrix. Now remember, over here the equation started with a Y. For a directrix, it's going to start with X. And that is going to equal your H value plus or minus your P value depending on the direction of the opening. Your axis of symmetry, whatever letter starts with your directrix, guys, your axis of symmetry is going to be that other value, and it's just going to be the same as the Y coordinate in the vertex. So let's just kind of get started on some graphing. I'm going to show you guys how I graph this stuff. This method for me tends to crank them out a little quicker. And what we're going to do is we are going to start with P. P is so important. So please remember, it is an absolute value. It's like a distance. So the absolute value is going to equal 1 over 4P. Now, guys, honestly, let's just look at the denominator. What times itself made that 4? P is just 1. So we're going to have a distance of 1 unit setting up a lot of stuff on this graph. And how did I get this one? I really just looked at this bottom part right here. Divide both sides by 4. 1 equals P. So that's how we're going to set that up. All right, so now that we have the most important piece of a parabola, which is the P value, we're going to go back and start filling in these attributes. I know that this graph opens down because my A value is negative and it starts with a Y. I know it's a vertical parabola. Vertex, plain old HK, so let's write -2, -3. And then the focus and the directrix, I'm actually going to plot it first. Then I'm going to fill in this stuff. Actually, for the directrix, I know it's going to be Y equals something. And whatever starts off the directrix, your axis of symmetry is going to start the other one. The latus rectum, or the official focal width, is this A value upside down. That is 1/4. Upside down is 4 over 1. We're just going to write 4 units. So again, I got that from the reciprocal of A. Okay, let's go ahead and plot the vertex at -2, -3. All right, and guys, I'm going to put a little V there just to remind myself that's a vertex because I plot things before I draw the curve. Now remember, we have a P value of 1, and it opens down. And remember, guys, the focus is inside the curve. So from the vertex, I'm going to go this distance down, and that's the focus. Then I'm going to go back to the vertex, go this same distance in the opposite direction, and draw a dash, because that's going to be a horizontal dashed line for the directrix. So when I plot these, I plot the vertex, go p-value one direction, that's your focus. Go back to the vertex, p-value in the other direction is your directrix. So let me go ahead and dash out this directrix. You do need to label it on your graph, guys. This is y equals -2. Now see, I already have my y. I just need to go ahead and write it equals a -2. Now let's talk about the focus. So the ordered pair for that focus, notice it's still in line with my h value. So that -2 is not going to change, but it went one place down, so the focus is at -4. Now, to draw the parabola, we are going to use this actual official width of the parabola, 4 units. Now remember, this always goes through the focus. But don't draw a line there. We're just going to measure it. So here's the focus right here. It's in the middle. And we know that we have a distance of 4 units. And if that's the middle, the official focal width is 2 places to the right and 2 places to the left. That's a total distance of 4 units. So now you can kind of start to see the shape of this curve. And guys, extend your branches all the way down to the edge of the graph. And then that's going to be a complete graph for a parabola using what we know about conic sections. So that's problem number 1.